All right, now that we know how to add and subtract rational expressions that already have a common denominator, we're ready to look at those that don't. And we're going to start off with an example. Let's add 2 over 9x plus 7 over 6x squared. Now, we're going to need a common denominator, and this is more challenging than problems we've looked at before because it's not just numbers in the denominator, we have variables as well. But what I want you to do is forget about the variables for just a moment and look at those coefficients, 9 and 6. If the denominators were just 9 and 6, what would our least common denominator be? What's the smallest number that's a multiple of both 9 and 6? The answer is 18. So if those denominators were just 9 and 6, the LCD would be 18. But we know that's not going to work here because we also have these x's. So the denominator is also going to contain some form of x. It might be x, like this one. It might be x squared, like this one. Maybe it's x cubed to contain all of the x's. What we need to do now is investigate to see what's going to work. First, I want to try letting x be the LCD and see if that's going to work. And if not, figure out what the problem is. Now remember, once we find an LCD, we need to figure out what the denominator was multiplied by and make sure that the numerator gets multiplied by the same thing. Now, if our LCD was 18x, to get from 9x to 18x, we need to multiply by 2. 9x times 2 gives us 18x. So that doesn't really present a problem, but we will have a problem when we look at the other denominator. If we look at 6x squared and we ask ourselves, what can we multiply 6x squared by to get 18x? The problem is that if we multiply by 3, we end up with 18x squared. We can't multiply by anything nice and end up with 18x because we already have an x squared here. So we're going to have to modify things a little bit. 18x isn't going to work. Let's try 18x squared. If we start with 6x squared and we need to multiply something to get to 18x squared, we can multiply by 3. So that's actually going to work here. In fact, let's do it. If we multiply the bottom by 3, we have to multiply the top by 3. 7 times 3 gives us 21. Let's go back to the 9x. What can we multiply 9x by to get 18x squared? Well, the answer is 2x. If we multiply 9x by 2x, 9x times 2x gives us 18x squared. So that works as well. We now have to multiply the numerator by 2x. 2 times 2x is 4x. So it turns out that the denominator was 18x squared. That is the least common denominator. Once we have an LCD, we keep that LCD, 18x squared, and we add the numerators. 4x plus 21 is just going to be 4x plus 21. There's no like terms. We can't combine them. And so we end up with 4x plus 21 over 18x squared. And that's going to be our final answer. Now, this problem we did kind of the long way. We inspected it, we tried to see what would work, we modified things. But in the end, we want a simple step-by-step process for finding the LCD, and I'm going to give you that right now. To find the LCD among rational expressions, first, find the LCD of the coefficients of the denominator. Here, the LCD of 9 and 6 is 18. And then we want to multiply this by the highest power of each variable in the denominator. So here we had an x and an x squared. The highest power was x squared, so we multiply 18 by x squared to get our LCD of 18x squared. All right? If there were multiple variables, like x's and y's, we would also include the highest power of y in our LCD. This is the only thing that's new compared to what we did in the previous video. We're just finding the LCDs now and then getting the new numerators just as we did before when we were adding and subtracting fractions. Let's do a couple more examples, and then you can look at the example problems linked below to see as many more examples as you want. Let's look at a subtraction problem now. Let's look at 3 over y cubed minus 2 over 3y squared. Again, we're going to need a common denominator. So first, we find the LCD of the coefficients. This coefficient is 1, and the LCD between 1 and 3 is 3. And then we have to multiply this by the highest power of each variable in the denominator. We've got a y cubed and a y squared. The highest power there is going to be the y cubed. So our LCD is going to be 3y cubed. Now that we've got our LCD, we need to figure out the corresponding numerators. To get from y cubed to 3y cubed, we had to multiply by 3. So we'll also multiply the numerator by 3. 3 times 3 gives us 9. Now, to get from 3y squared to y cubed, we needed to multiply by y, because y squared times y gives us that y cubed. So in the numerator, we also have to multiply by y. 2 times y gives us 2y. Once we've done this, we can now subtract the numerators. 9 minus 2y is just 9 minus 2y. We keep the LCD below, and we get 9 minus 2y all over 3y squared. Let's do one more of these. Let's take a look at x plus 3 over 6x plus x minus 4 over 8x. This is a little bit more involved because our numerators have more than one term, but we can still do the problem. We need to start by finding our LCD. If we look at the coefficients, the least common denominator between 6 and 8 is 24. And then we have to multiply this by the highest power of each variable. Each of these x's is just x to the first, so we need to put in an x, or x to the first, in the denominator. And so our LCD is 24x. Now we need to figure out what the new numerators are. To get from 6x to 24x, we have to multiply by 4. So we're also going to have to take the numerator and multiply by 4. If we do that, x plus 3 times 4 gives us 4x plus 12. Now for the other one, 8x, to get from 8x to 24x, we have to multiply by 3. So we're going to have to multiply the numerator by 3. X minus 4 times 3 gives us 3x minus 12. Now that we have a common denominator and we have the new numerators, we can add the numerators across. 4x plus 3x is 7x. And then 12 plus negative 12 is 0. Those 12s cancel. And we keep the common denominator of 24x. So we've got 7x over 24x. And there's one more thing we can do. There is a common factor in the top and bottom that can be canceled. That common factor is x. So when we cancel that out, we're left with just 7 over 24, which is our final answer. Please go through the videos in the link below to get more practice finding the LCDs and adding and subtracting rational expressions.